Okay, Bismillah ar-Rahman ar-Rahim. Salatu wassalamu ala nabiyyina Muhammad wa ala alihi wa sahbihi ajma'in. Okay, so this is the first lecture in the course, and today I'm going to provide an overview about advanced deep learning concepts, starting from the perceptron, which is like the core of a neural network structure, and until how we reach the transformer technology that enabled the large language models and language modeling. So first of all, let's start from basic definitions about artificial intelligence, machine learning, and deep learning, and what is the difference between them. Of course, as you can see from the picture, artificial intelligence is like the big umbrella, and it's quite an old technology, starting from the 50s. And at that time, it started with broad concepts of machine being able to carry out tasks, complex tasks, in a way that we could consider as smart. So several techniques have been developed back into the 70s. Even the starting of neural network as a concept started from that time. But of course, it was only a theoretical concept because, as you know, neural network is a concept that requires extensive computing resources, and at that time, there is not enough sufficient computing resources. So some of the artificial intelligence technique, like constraint satisfaction problems, heuristic search algorithms, genetic algorithms, all of these were part of the big umbrella of artificial intelligence. And then, so the concept of artificial intelligence have converged toward the concept of machine learning. And these are more specific types of artificial intelligence techniques, where we take use of data to learn something or some patterns out of this data. And several applications have emerged, like, for example, spam filter detector. Okay, so it was based on machine learning techniques to classify emails whether they are spam or not spam. This is binary classification. And until 2010, 2012, of course, the neural network concept was quite old, but it doesn't have sufficient resources to rise. But it has the ability to rise back in 2012 in the challenge, ImageNet challenge. And deep learning is a subset of machine learning models that are based on neural network. So basically, everything is around neural network. Machine learning using neural network, it's deep learning. That's pretty much it. And it started from tasks like image classification, and then has emerged to other more complex tasks like image detection, image segmentation, image captioning. We integrate both NLP and image computer vision processing. And until where we are now at the large language model transformer era with very advanced deep learning models. So what is the difference between traditional programming and machine learning? So when you do traditional programming, usually you have data, which is your input, and you want to develop a program, so you have the ability to develop a program to transform this data into an output. For example, you have certain numbers, you want to calculate their average, or you want to do some kind of analytics. So it's easy. You can have your data, you can create some kind of algorithms that will transform this data into a certain output. You want to develop a search algorithm, you want to perform any kind of activity that allows you to transform your data into an output. And this is possible when we have the ability to develop the program. The program is something possible to reach. But in some cases, the pattern of the data is too much complex, such that it's impossible to write manually a program. It's impossible. And I will give you some examples later on related to computer vision. And when the program is very difficult to develop, so we will use the data as input. And of course, in particular case of what we call supervised machine learning, we need to have the output with this data. So every input will be mapped to an output. Okay? And in this case, we will try to infer the program, because the program, it's the unit that will transform this data into the outcomes, okay, or into the output. But in this case, the program is very difficult to do manually because the pattern of the data or the features of the data are very complex to develop. And I will show you several examples. And this is what we call pattern recognition, okay? Because every data would have some kind of patterns on how to be transformed. For example, if I take an image and I would like to recognize the face. So an image is basically an array of numbers. So can anyone develop a program that will convert an array of numbers into the name of a person? It's something almost impossible. Because the patterns of an image, so the numbers of the image, we cannot understand them as humans. So we need to develop complicated programs that are able to discern the features or the complex patterns that we can learn out of this data. And this is the concept of learning. Learning, it means we will take use of the data and its corresponding outcome to learn the patterns. And we will discuss a few examples here. And this is the difference between traditional programming and machine learning. So before going deeper, we need to understand what is data and what are the categories of data. We have two types. We have simple type of data, which is a structured data. Like, for example, you have a table or a CSV file or a database table. This is something simple. It's structured. It has a certain number of rows and a certain number of columns. And I understand pretty much the semantic of every value inside this data. And this is what we call structured, predefined format. It's basically stored in databases, spreadsheets, and it's easy to search and analyze. Examples like Excel files and SQL databases. But most of the data is not structured. Most of the data is unstructured. It has complex patterns. No predefined organization. For example, text. Okay, a text can have different type of lengths. It can have different type of words. There are several languages. Images, the same thing. I will show you what is an image from computer perspective. Now you can see this is a cat, but for a computer, it's something completely different. It's just an array of pixels. And every pixel is a number. So you can imagine just a small picture, 1,000 by 1,000, okay, 1 million, 3 million pixels. How can you convert these 3 million pixels into a classification or giving what is inside this image? Okay. So this data is more complex to analyze, like, for example, emails or media posts, and we want to get information out of this unstructured raw data. So machine learning basically is going to transform unstructured data or structured data into a meaningful information based on the task that we want to assign. For example, in social media posts, imagine that you have millions of posts about a certain topic, and you want to know the sentiment of people. Are they happy or unhappy about a certain topic? So using machine learning technique, we can just process text and transform any text with different lengths to either positive or negative. This is a very simple example of sentiment analysis. So basically, all thing about machine learning, deep learning, is data transformation from one space to another space from, let's say, mathematical perspective. So machine learning is divided into two main categories: supervised learning and unsupervised learning. And the difference is, in supervised learning, we need to have both the input and the output. Okay, because we're going to learn the patterns by making the mapping between the input and the output. And these type of problems are much easier than the unsupervised learning, where we have only the input and you want to infer any kind of relationship or hidden relationship between these inputs. So for supervised learning, we have two main categories depending on the type of the output data. It can be classification if your data is categorical, and it can be regression if your data is numerical. Okay, what is a categorical data? Non-numerical. We have defined certain number of outcomes. For example, I have two outcomes. This is binary classification. Or I can have multi-class classification if I have 3 possible outcomes, 4 possible outcomes, 10 possible outcomes, 1,000 possible outcomes. This is still classification. So the output space is discrete. and finite. And here the output space is continuous. It can be between 0 and 1, but you have infinite number of possibilities. So this is the difference between classification and regression, which falls under the supervised learning category. And we have completely unsupervised learning. Imagine that you just have a data. Okay, now these are separated by colors, but imagine that this data without this color, without these boundary lines. So you would like to infer any kind of relationship, which data is close to each other more, and this is what we call clustering. So we try to make a clustering of these data. And the problem that there is no single solution. Depending on some parameters that we call hyperparameters, we can come up with different type of clustering techniques or grouping techniques, but they will be able to minimize some kind of metrics. Sometimes we call it loss, sometimes we call it objective function, depending on the problem. And you have reinforcement learning. It's a different category, and basically this category used in robotic and control. And one of the most famous applications of reinforcement learning, self-driving and autonomous driving cars. So how do they learn here? So basically they are going to learn from trial and errors. And this is how we learn when we were kids. So usually when we try to do something wrong, our parents will say, okay, you did something wrong, or there's kind of penalty that you're gonna have. And if you do something good, they will be happy, maybe they will applaud you. So you will know what is good and what is bad. And this is how reinforcement learning actually works. So basically it starts from simulation perspective. We do that. We do the trial and error in simulation. Now autonomous driving cars, we cannot take a real car and just make trial and error. It's going to crash from the first time. So usually they collect a huge amount of data to train a car in simulation to drive autonomously into a realistic environment. And then they will have kind of a control algorithm, and then they will try it in a real-world scenario and check whether it works 100% or they need to make more adjustment. So these are the three types of categories of machine learning based on the problem and the type of outcome as well. Any question? Okay, now we understood the different type of machine learning techniques, but what's the difference between machine learning and deep learning? Okay, so machine learning basically, so any kind of learning, first of all, we need to do feature extraction. What does it mean, feature extraction? You will have unstructured data. Think about an image. Small image, as already mentioned, 3 million pixels. But should I process all these 3 million pixels? No, these 3 million pixels, they would have limited number of features. You can do that. You can process the raw data, but usually it will lead very inefficient outcomes. So first of all, we need to extract the most relevant part of the picture or the most relevant part of the text. And this is what we call features. So in the era of machine learning, these features were manually extracted by humans. There are like simple techniques on how we can extract features from image, from text. And then we will use type of classifier, which is a machine learning technique, that will make a classification. It can be a dense neural network or support vector machine or random forest. There are many techniques of machine learning to provide you an output. So the problem is that feature extraction, when it is done manually, it's not accurate, it's not efficient. And this is why most of the machine learning technique, they were not able to perform on complex tasks, especially in computer vision. And I will show you how neural networks started to have momentum over machine learning back in 2012. And the difference with deep learning is that deep learning, it has an automated feature extraction. And since everything is based on neural networks, so we're going to learn the features and we're going to learn the classification or the regression problem both together, whether it is an image, whether it is a text. So neural network have the ability to do both tasks, feature extraction and also classification or regression based on the data type of the outcome. Does it make sense? Okay. Now, another difference is in terms of performance. So the performance of machine learning and deep learning, of course, will heavily depend on the training data size or the data, your data size that you will use for training. So usually when you have small amount of data, we should not observe too much or big differences between using neural network or classical machine learning techniques, but the difference will become tremendous or much highlighted when the number of data size increases. And this is because deep learning, it has the ability to learn the features. And when you increase the data, you will provide different type of patterns, so you can have generalized model that can be applicable to different type of contexts. And this is what actually matters about the accuracy. What we can say that we have an accurate model when your model can perform equally and correctly in any kind of situation. It means it's general. And the general model can be obtained when the data is large. Okay? So let me give you just a funny example that happens to me. You know, my daughter, when she was like maybe 2 or 3 years old, I show her a picture of a guy with a beard. It was James Harden, like a basketball NBA player. And I say, who is this guy? She said, this is my father. You know, because she has only a small sample size, which is her father. This man with a beard is just my father. And you know, this is how machine actually works. If you don't have some sufficient number, now if I ask her the same question, of course, she will be able to discern because she has already learned a lot of different type of pictures. So her model is now more general. So the training sample size will actually make this model more accurate. They have the ability to understand different type of scenarios. نفس الشيء في أي شيء. مثلا when you train a self-driving car, imagine that you train it only on pictures in Los Angeles or San Francisco, and then you want to apply it, for example, into a farm context. It's not going to work because it has only seen pictures from a particular domain or a particular environment. So in order to have generalizable model, we need to train on different type of scenarios, on different type of use cases, such that if I put this model into a different place, it's going to work. But in reality, it's not always the case. I mean, there is no deep learning model that will work forever anywhere. It can work, but usually we need to do some kind of customization based on the complexity of the tasks. Okay? مثل الآن مثلا large language model, they work in most of the cases, but in a very particular case, they may fail. So in this case, we will have to do what we call fine-tuning. Now in healthcare, if you use ChatGPT for healthcare, it can respond maybe most of the questions, but probably not all the questions. If we take questions for very specific topic that the model was not able to be trained sufficiently on, it may fail. But we can circumvent this by either doing fine-tuning or training the model over larger amount of data. So the impact of data size is really very important. You know, the first thing that we need to care about, you know, the biggest challenge in deep learning and machine learning is data. If you have sufficient amount of data, you solve all your problem, and then you have the computing resources. You need to have sufficient computing resource because when you grow in scale, you have a larger neural network. Look, in general, it's going to provide you better performance, but you know, you need to spend a lot of money, a lot of resources. You need to have, now we talk about thousands of GPUs, tens of thousands of GPUs to train a deep learning model for large language models. So the two biggest issues is the scale of the data and the budget, the financial budget to have a reliable model. At smaller scale, like smaller scale computer vision algorithms like YOLO and so on, we can train these on 1 GPUs, 2 GPUs. But some complex models, they actually require much powerful resources to be trained on. And look at the challenge. Now, when we talk about computer vision, all of you can quite instantly know that this picture is for a cat. But look at the computer. You know, this is what the computer is actually seeing, just numbers. Now, how can I make a program that will convert this number into either this is a cat or not cat, just a simple binary classification problem? So it's quite challenging, and it's not only one-dimensional, it's three-dimensional. We have red colors, green colors, blue colors. But this cat, you know, it has some features. How do you know that this is a cat? You know, this shape, you know, these edges from here, if I just take, you know, I make a filter, maybe a Laplacian filter, I only extract the edges, I can understand that this is a cat. So edges is one possible feature. The color, you know, the location of eye with the nose, all of these are features of a cat. Now we need to develop sophisticated techniques that will be able to extract these different features. There is no one feature here. There are multiple features. But we cannot do this manually. If I do that manual cut features, edges and so on, it will fail for other type of categories like cars or persons or any kind of object. And this is the beauty of neural network or convolution neural network. It's the ability to learn different type of, I don't know what kind of feature it's going to learn because I will have several filters. And these filters, all of them will be learnable and based on parameters. And the good thing, all these parameters are just weight and biases. A neural network, do you know how a neural network works? It's basically a linear combination of the features added to nonlinear function, which can be sigmoid and so on. And you can imagine thousands and billions of these weights and biases organized in certain architecture to learn these features. So at the end, using backpropagation, and gradient descent optimization techniques, we are able to reduce the error, because if you start from random numbers, weight and biases, you're going to have random outcome. But using gradient descent and derivatives, we are able actually to come up to conversions for these complex problems. Okay. And things started back in 2012. This is the start of the era of neural network. And this was based on the ImageNet challenge. And it started from 2010. And these 2 years were based on machine learning models. They used SIF techniques for manual feature extraction. And they were able to get classification error, 28% here, 2010, and 25% in 2011, based on machine learning techniques. But surprisingly, AlexNet back in 2012, it was the first model that used convolutional neural network applied to the ImageNet challenge. And suddenly, instead of only saving 3%, they saved 16%. And this was triggering for the scientists. This has to come up with something more interesting than the traditional machine learning techniques. And at that time, also GPUs started to emerge with NVIDIA GPUs and so on. So there are more hardware resources. And from that time, all these proposals come from companies like Microsoft, Google, And I consider that from that time, the AI research is no longer with academia. It becomes completely industrial based. Only big companies and with also joint collaboration with universities like the Waterloo University with Geoffrey Hinton and so on. The industry have made tremendous change in the artificial intelligence as compared to academia starting from that era. And of course, after 2019, with Google, now Meta, large language models are almost based with companies, and there are a few other models with universities as well. Okay, so from 1 year to the other, there was improvement. Now 16%, 11%, 7%, 6% error rate, and finally below 4% error rate. And this is the first time that they were able to exceed human level performance. I mean, there are humans that have been classifying also the same images. They made 5% errors because these images are low resolution, and there are 1,000 classes to make classification. So since that time, convolutional network started, and then we have from NLP perspective, recurrent neural network, LSTM, for machine translation and for different type of problems. So how do convolutional network works? So they are based on two parts. One part is convolution, and the other part is what we call fully connected layers. Do you know what's the difference between both? Okay, what's the purpose of this part? So this part is just for feature extraction. And at the end, I will start by a picture. It will go through convolutions. I will explain. Did you take convolution? Do you know what is convolution? Okay, I will explain, no problem. So just now, think about this. I have a picture. I would like just to take the most important feature of that picture. So all this mess is just to create one vector. كأنه ملخص. Okay. And this vector, okay, so it will result from a picture to one-dimensional vector, which we call the feature vector. The vector represents the features of that picture. And then I will use a classical neural network, which we call fully connected or dense neural network. And this has the ability to do either classification or regression based on the outcome. فكل التغيير اللي صار انه this part that extract the features has replaced human by a neural network. And then now every neural network is replacing human. Large language models are replacing human in many things. So we started from here to replace the manual feature extraction made by human by learnable parameters. And this is based on two important operations. One is called convolution, and the other one is called max pooling or average pooling. So the convolution is based on the concept of filter or kernel. Maybe next time I can provide you an illustration of convolution, or I have also some recorded videos if you want to have more detailed information. But basically, I'm going to make a filter, for example, 3 by 3, and this filter is going to reduce the dimension. Okay, look, it will reduce the dimension, for example, 224 by 224. This is the first layer. The second layer will make it 112 by 112. So I will take this filter and apply it to a region here, and then this part will be reduced. I will take the so you have a filter, and I will make matrix multiplication of this filter by the same region. Okay, so 3 by 3 is going to result in one number. Another 3 by 3 to result in another number. So every time I go deeper, I will reduce the dimension. And then I have another operation which is max pooling. ناخذ مثلا 3 by 3, I have 9 element. I will take the maximum value. Why the maximum value? لأنه الpicture value is an intensity. I will take only the highest intensity among 9 values. Okay? وهذا اللي يعطينا الفيتشرز. معنى البيكسل اللي عنده high intensity it represents better feature than a picture with low intensity. لأنه low intensity it's dark. Imagine that you have a picture that is completely black, there is no feature. وهذاك علاش احنا ما نشوفوش في الظلام. Everything is black, we don't see any feature. It's the same thing. Basically it's going to extract the most important concept in some magical way. Okay? Of course we use gradient descent learnable parameters to optimize the feature extraction and also to optimize the classification or the regression. Okay, this is how convolution neural network basically work. And there are different type of architecture. VGGNet, it uses this type of architecture. They go a little bit deeper. بعدين دخلوا فيها batch normalization to improve the stability of convergence خاصة لما يكون عندك deep neural networks. فthere are ResNet, residual networks اللي نستعملوا some of the features here to embed it into the future layers. So they made different type of combinations to improve the ability of image classification. But they have also made it for image detection. اللي I will detect the picture and also localize it within the image. وهذه تستعمل both classification and regression. Classification to tell what is inside the image. It's a class. Or regression, it will give me the location, XY coordinate of the center point and the dimension of the square. هذوما continuous, so it's regression. Is it clear?
I have a question.
Yeah.
What is VGG 60?
Yeah, this is VGG. Yeah, this is the proposal made in 2014. I don't remember whether this means something, but this is like the proposal, the winning proposal in the ImageNet in 2014.
It's a type of CNN?
Yeah, it's type of CNN. And we started with AlexNet, but then we have AlexNet in the beginning, but then GoogleNet, VGGNet, ResNet, EfficientNet. So there were several proposals of image classification.
يعني كل proposal يصير أحسن من اللي
It has reduced the loss in the ImageNet. Okay? Yeah.
From my understanding in the previous slide.
Uh-huh. Yeah. Sorry.
Yeah, in this example, it's the 7 by 7 part for the max pooling. It represents a single picture extracted, right?
Yeah, this is a feature vector extracted, yes. Yes. So at the end, we will have this one. Look, 1 by 1 by 4096. This is the dimension of the feature. وبعدين ندخل على dense fully connected network. So we will have a dense, okay, or 1 by 1 vector multiplied by the number of features. Okay, so all this picture is just summarized in one vector. And then this vector will go into a classification layer. Okay, so what you need to understand, this is a feature extraction layer, and this is a classification layer. As simple as this.
So, Doctor, I noticed each time we go by half. Is it always the case?
Yeah, I mean, it's kind of typical because 2 is kind of a magical number. Okay, so usually we start from 16, 32, 64. You know, there is no reason to say you cannot change, but you know, in terms of efficiency, because byte is a power of 2.
Yeah.
So yeah, so it's a matter of encoding in the memory. It's compatible with the memory encoding. Okay. Any other question? Okay, so this is a summary of the deep learning evolution in from time 2010 to 2015. And then computer vision tasks, they have evolved. And the architecture that I presented is only about image classification. What does it mean? I give an image, and I will tell you what is inside. And this assumes that I have only one object. Of course, if the image is bigger, and there is image classification, and there are some other pictures, maybe it will provide noise to reduce the classification accuracy. But if the image is focused on the object, so in this case, I can say, okay, this picture corresponds to this object. And then they also worked on classification plus localization. I don't only say that there is a cat, but where is this cat located? So I will provide the center point and the corner point here, so I can know that there is a square around this picture. So I can localize the picture classified. And the more complex problem is object detection. Now, if I say classify this picture, I cannot say whether it is a cat or a dog because there are multiple objects. So here we talked about object detection, and the problem becomes more complex because I need to detect all type of objects. First of all, I need to localize them, make boundary boxes, and also classify every boundary box what type of object it is. And the most popular techniques for object detection, YOLO. I think everybody has heard about YOLO. It's fast and accurate, and now it's kind of the standard. But back in 2016, 17, 18, there are other techniques like region-based models like RNN. It's one of the famous techniques, but now YOLO is kind of the standard. And surprisingly, the inventor of YOLO just dismissed AI because of ethical issues that can come out of his invention, and then it was taken by other people, and now it's being developed by a company called Uralytics. Now we reach YOLO version 11. Okay, it's pretty much easier to use than the earlier version of YOLO. Like the latest academic version that I know about that we have used is YOLO v4, and then it becomes more commercial oriented, you know, by industrial people. Okay, so this is object detection. And here we have both classification and regression. So regression, it determines the bounding boxes, their location, and classification, I have to classify which object in every bounding box. And more difficult than this is instance segmentation, which I don't only find the bounding box, but the whole المحيط كامل يعني بالنسبة للصورة. Okay, and this is even more challenging. And this instance segmentation this is what we use in self-driving cars, because in self-driving cars I need to know, I make a complete segmentation of the environment. This part corresponds to trees, this part is pedestrians, this part is a car, and I need to know what is the drivable surface. So segmentation is basically what used in self-driving cars when we have multiple objects. And it's a very complex problem, but now this type of problem becomes quite easy, you know. Back at the time, the most challenging issue was about labeling data. Now, if you want to make an object classification about car, you need to label cars. I remember we had a project about car classification and detection for surveillance platform that we developed, we had to collect 40,000 images. Can you imagine? And these images has to be labeled manually. So it's a huge amount of work. Now currently with some tools like RoboFlow and some other tools, just click on the picture, it's labeled. You don't need to make these manually. Some of the projects on segmentation, I just abandoned them because of the cost of labeling, so to make segmentation of the objects. But now it becomes easy. I mean, if you want to do any kind of hands-on activity on YOLO, it's pretty much straightforward. You bring your images. With RoboFlow, you just click on your object. It will create the data set. You plug it, one instruction line, and you have a trained model on YOLO for a particular object. But it was hard, before, because, and I think Meta, it's one of the most advanced companies in developing these computer vision models and facilitating the use of computer vision models. So some of the application is image understanding and generation or image captioning. So in this application here, we have a more challenging problem. It's not only classification. This is a dog, this is a bicycle, this is a man, but I want to make caption generation. I want to tell what is inside. And this is quite an old application. I mean, from 2014, 2016, we have already image captioning. But of course, now, if you put this into a large language model, it's going to provide you all type of details, provide you a description about these constructions, about the man, about the bicycle, about the road, It's quite impressive. And this is why LLMs are impressive, because they can do any kind of task. Now, computer vision before, it can do either single task, classification, captioning, segmentation, but now LLM, it can do almost everything. It's quite impressive. Okay, so this was quite an old application trying to understand or semantic understanding of a picture by writing caption about it. And here it uses both, it uses CNN to extract the feature. Now, for example, I can run a convolution neural network to detect that I have a man, a bicycle, and a dog. And then I can put the picture with features, the feature vector of the picture with this text, and provide it encoded into a recurrent neural network to generate a text for this picture. Okay, and this was kind of initial language modeling. Okay, because this is part of what we know now as visual language models. Visual language models are very advanced. Now, in terms of the healthcare, if you provide an X-ray to a visual language model, it can provide you a complete report about that X-ray or CT scan. They were trained to do that. But back at that time, we need to use a combination of neural network in order to get these type of outcomes. So the challenge is that we need to large training data sets are required, and complex visual relationship remain difficult. So they were successful to some extent, but we cannot say that they are generalized. They were not popular such that when you know that something is generalized when you find commercial applications in the market. But this was very, very limited. But now we can see plenty of applications in any kind of business sector. Another big advancement, and it was considered as the biggest advancement at that time in AI, is generative adversarial networks, GANs. And this is the first model of generative AI, because it was able to generate data, realistic data, which is fake, but it looks like realistic. وكلكم تتذكروا الديب فيك والفيديو الشهير بتاع أوباما when he say I'm not the guy that is talking right now and so on. It was based on GAN actually. And what is the idea here? It's simple and complicated, but it's a smart and brilliant idea. So the idea here is we would like to train a generator of, let's say, pictures, or it can generate text or anything. So pictures, for example, I want to generate a realistic picture. So first of all, this generator will start from noise, random noise, of course, and there will be a discriminator. هذا عبارة للشرطي يقول لك هذه العملة مزيفة ولا مش مزيفة، أو الداتا اللي جبتها مزيفة ولا غير مزيفة. We will provide a noise, and the discriminator will compare the outcome of the generator with the real data. And when there is a discrepancy, it will say, no, this is fake. What does it mean this is fake? From learning perspective, the loss is high. This is how we know. So this generator will be trained. I have a big error, so I try to improve myself. Okay, so doing that several iterations, at the end, the generator will come point in time, it will fool the discriminator. And this means that now he's able to generate pictures very close to the grounded truth. واضحة الفكرة؟ So the loss will be reduced using optimization techniques until the generated pictures are very close to the real pictures. And at some point in time, we will not be able to differentiate what is fake and what is realistic. And there are some pictures where they provide you real pictures and fake pictures, and you are not able to discriminate which one is fake and which one is realistic. Yes?
The discriminator, is it layers?
Yeah, it's a neural network. Yeah, with convolution. It's based on feature extraction and comparison between the features, defining a certain loss. Of course, the difference here is the definition of the loss on how to differentiate between fake and there are several techniques proposed on GANs. And it was used in different type of applications. This was the starting application, but later on domain adaptation and several other areas. So now, technically speaking, we start from a latent space, which is kind of random noise in the beginning, and these are the features. We will add noise to this latent space, and we will train the generator to generate fake samples. And the discriminator will compare the fake sample with the real sample. It will result into a loss, and then based on the loss, we will fine tune. Doing that several iterations, we will be able to learn about generating it.
Why do we add noise?
For generalization. Okay, so not to memorize a sample. So usually the noise here is to help the generator to learn in a more general way. مثل ما نعمل regularization technique بعض الأحيان to remove the overfitting. Yes. Of course, this is the most famous application of GANs. It's used for different type of application. Image generation, that's what we talk about. Data augmentation, هذا حل مشاكل كثيرة جدا في التريننج. يعني sometimes when we don't have sufficient amount of data, sometimes it's difficult to bring data from outside. So GAN, it was used to generate samples out of مثلا I have 1,000 image, but I need 10,000 images. But I couldn't find, it's hard. I can use GAN to generate realistic pictures and then put them back into my training data set to have a better trained model. In super resolution, هذا استعملناه في بعض البحوث to improve the resolution of a picture, low resolution picture. واستعملناه في البحوث في license plate. كنا عندنا بعض الالجوريثمز to find the numbers and letters of Saudi license plate. لكن بعض الأحيان with the camera it has very low resolution, so we cannot differentiate easily. Using GANs, we were able to augment the resolution so that the classification of the characters is better, to improve the classification of. And it was used in several aspects for super resolution, in text to image generation, generate images from textual description, medical imaging, generate synthetic scans for rare condition anomaly detection that could be used for data augmentation, gaming and virtual reality, and also domain adaptation. So domain adaptation, this is one of the things that we have worked on. And in summary, when you do a classification model, and I talked about this in self-driving cars, if you make classification model of buildings in Europe, and you have a data set from Europe, and you build a model to classify buildings, trees, green areas in Europe, and you want to take this model and apply it to Saudi Arabia. The landscape here is different from the landscape there. So one of the solutions is just you need to collect a data set specific for the Saudi landscape. That could take time and resources, and sometimes it's not easy, how to take aerial images. So one of the ways is to use GAN to transfer these pictures. Instead of looking like they came from Europe, they will look like they came from Saudi Arabia. We will train the GAN to generate pictures such that they come from the domain of Saudi Arabia instead of the domain from Europe. We have a paper on this. If you are interested, I can share the link so to see how that was possible. And this is what we call domain adaptation. Yeah, that's the paper that we have worked on. And our problem here was to do semantic segmentation model, okay, on two different data sets. So this is the source domain. This source domain, we have a model that is able to classify or to make segmentation. Segmentation is even more difficult, you know, segmentation of cars, segmentation of buildings, and so on. And we want to use the same segmentation model across another domain. This is our target domain. And both are aerial images. This has a resolution of 5 centimeters per pixel. And this has a different resolution, 9 centimeters per pixel. This will affect the segmentation quality. This is based on image sensor, RGB camera, like the cameras that we use every day. This is based on near-infrared camera. This is why it looks like red. Okay, this is located in Vying. This is like a city in Netherlands, and this is in Potsdam. And then we used GAN to take a source domain image, and we try to generate target image from this domain. So of course the discriminator is going to differentiate between fake sample and real samples, and at the end we were able actually to generate. And then we can use the same classification model. What we will do, we will convert this image into this domain and then apply the segmentation. واضحة الفكرة؟ الآن you have a segmentation model, it works perfect on this domain, but will not work perfect on this domain. So what we want to do, we want to translate this image from this domain to this domain.
Okay.
So we will do image translation.
So the size is the source.
Yes, we have the source and we have the target. Okay, so we want to translate this source into this target. So it looks like it was taken from infrared camera, because we have two different domains. And then I can use the same model. If I translate the image from one domain to another, I can use exactly the same trained model. I don't need to retrain another model.
Is this considered synthetic data?
It's kind of, yeah, it's kind of, but this is what we call domain adaptation more than synthetic data. It means creating a data from based on a certain sample, like for data augmentation, you know. Yeah, this is, we don't say that this is a data augmentation. This is another application which is called domain adaptation. It means translating a picture from one domain to another. مثل style transfer. في كان عندي, I have one picture مثلا, I can take a picture of Picasso and a picture of Al-Madina, and I say I would like to draw Al-Madina mosque like Picasso style. So this is called the neural style transfer. يعطيك نفس المسجد لكن كأنه لوحة فنية.
صح.
اي هذه عبارة عن translation. طبعا قبل كان يتسمى image style transfer. We take a content image and the style image, وبعدين it apply the style on the content. الGAN, it can do similar things, but this particular type of application is called domain adaptation or image translation from one domain to another. Okay. Synthetic images are images that looks like real images. هذا نسميه synthetic images. يمكن نستعملهم for image generation and for data augmentation as well. واضح؟
طب دكتور،
Yes.
الصور اللي تيجي تكتب مثلا two things بعدين مثلا في التكست جنريشن شو اسمه زي دالي يستخدموا نفس هذه نفس هذا الكونسبت.
لا DALL-E الآن يستعملوا large language models. These are visual language models, more sophisticated. إيه.
تعطيهم two مثلا I want this style using this.
نعم نعم. لا الفيجوال لانجوج موديل are based on transformer. احنا الآن we're taking it step. احنا الآن وصلنا للنيورال نتورك. كمان الكمبيوتر فيجن وصلوا في الكمبيوتر نيورال نتورك. شوفوا كيفاش وصلنا لللانجوج موديل. كيفاش وصلنا للترانسفورمر. Of course, we need to understand the limitation of this model. This model have limitations, by the way. Okay, now this is from computer vision perspective. Let's look at the NLP perspective, natural language processing models. طبعا the classical techniques are recurrent neural network. We will have a complete lecture about their details. And these are applied into sequential data. شفتوا الآن? The pictures are not sequential, although later on they were considered sequential. لكن they are they have like a static form. I know they are matrices, they have certain number of rows, certain number of columns, and 3 layers, you know, everything is non-inverse. But here, it's sequential. A text, it has dynamic length. You can have short text, you can have long text. So in order to process this using recurrent neural network, we need to have something that will accept a sequence. And this is why we use recurrent neural network. It will process the sequence recurrently, okay? And sequential data patterns to discover the data patterns of a sequence. Of course, because they have long, you know, the sequence can be very long, so we can have issues of vanishing gradient. لأنه في الأخير there are computations. طبعا there are normalization techniques to reduce these issues and so on. Limiting the long-term dependencies. Rule of thumb, when you go deep into the network, you have problem of computation and stability. طبعا نعدلوها بمسألة النورماليزيشن والباتش normalization at each layer, but still there could be some issues. In order to avoid these issues, so we have LSTM was proposed as an alternative to or an advancement to RNN to also consider memory in processing the sequence so that it's able to know the dependencies of possible words. And then we have also gated recurrent neural network. It's a simplified version of LSTM, which combines update and reset gates for faster training with fewer parameters. This is like the conceptual schema. No need to go into details right now. We will have a complete lecture going into the internal mechanics and how the memory is actually constructed in LSTM and also in GRU network. But you know, what you have to know, this is the evolution of NLP techniques with neural networks, started from having like model that will run in sequence to learn patterns. And here we have learnable parameters with different sizes based on the complexity of the model. And then we introduced memory in order to capture the dependencies between the word. مثلا يمكن تكون عندي memory ب5 6 كلمات ولا ب10 كلمات. لأنه يمكن تكون كلمة الآن عندها علاقة بكلمة جي من بعد. ال RNN no, it's stateless. ال LSTM, it can carry information from the past to be used for training the present. Okay, and this is the concept of memory. طبعا these limitations were the standard for several years until 2018, 2019, start of transformer. And they were able to perform very advanced tasks in NLP, like text classification, okay, which means categorizing the text, like sentiment analysis or spam detection. Spam detection is binary classification. Sentiment analysis can be binary or multi-class. Like I can classify text whether it is neutral, positive, or negative. And you know, sentiment classification, this is used now in social media. You know, everything that you write, it will be classified. So this is why they can make a complete profile of every user on social media based on your writing. Okay, it's not only positive, negative, but they can know which type of what categories of news you're watching, or what are the most websites that you have interested on, and this is used in marketing. Okay, in Amazon, for example, when you click like for a product, you know, they will analyze this. You know that you like electronics or fashion or any kind of different type of products to provide you a recommendation system. And this is part of the recommendation system. It's based on analyzing the text and provide you recommendation based on your history. And there are other applications like information extraction. I can extract the entity names or the city names from a text. Information retrieval, conversational agent, but they were not very sophisticated, this chatbot at that time. Question answering system. So different type, anything related to processing a text was solved by RNN, LSTM, and GRU techniques. Also, time series prediction. Anything that comes in sequence. Time series prediction, if you have data in the past, you want to forecast the stock price, you want to forecast the weather conditions, you can use these type of techniques in order to do that. In one of our recent works, we used GRU networks, which is the like LSTM, in order to predict the trajectory of a drone to be able to intercept it. So what we do, we can take the history of the drone trajectory, and then we can make neural network to say what will be the trajectory of the drone in the next 2 seconds. And this will help another drone to go and intercept the drone in real time. Okay, so this type of techniques is used in different type of application for time series forecasting, for general application like spam classification, social media analysis, retail catalog extraction, health record analysis, and pretty different type of application. Search engine as well. But you know, all of this is kind of the legacy, and until there was a paper called Attention is All You Need. So this paper was the revolution of natural language processing and later on in computer vision, because it has introduced the concept of attention, al-intibah. So this key paper is from Ashish and al., published in 2017. You know, look at this paper. It's, I think, the highest cited paper ever. You know, just in 5 years, 1,555 citations, just one paper. Okay. You can see in 2024 still being cited almost 50,000 times. It's impressive, you know. This paper is kind of revolutionary paper, because everything now we have in AI is based on this technology. Okay, and this is known as the transformer architecture. Okay, that is the core contribution, and it has dramatically replaced RNN and CNN with a model based on self-attention mechanism. And today I will introduce intuition about the self-attention mechanism. And it provided the basis for modern generative AI and large language models. Okay, so this Attention is All You Need paper is based on the concept of self-attention, as we already mentioned, and we will introduce this in today's lecture. So this is the block that made the difference about self-attention. I'm going to briefly explain, because we need the full lecture to go into all these details. And the key innovation in the self-attention, it enables the model to focus on the relevant part of the input sequence, regardless of its length. طبعا الإشكال اللي كان يعالج فيه واشتكلموا فيه هو أنه ال LSTM وال RNN, they don't have the ability to capture the relationship between all different words into a sentence، خاصة لما يكون السنتنس كبير جدا. Why? ال LSTM فيه memory, but what is the issue of that memory? Short term. If you have a memory of 20 words, أنا عندي 100 كلمة. الكلمات في السياق الواحد عندها علاقة. وفي language modeling, I need to understand the relationship between all these different words. I should not limit myself into just memorizing or understanding the relation of 10 words in a sentence. This will be limited. Okay? لو شخص فقط يتعلم اللغة بأجزاء من الجمل، مش لما يتعلم اللغة في سياقات مختلفة. احنا قرأنا نصوص كثيرة جدا. We have read a lot of text. And سبحان الله بقدرة الله عز وجل التعلم يصير من القراءة هذه الكل. أنه مش نعطيكم بعد مثال. You will understand clearly how did you learn the language. And this is the same way that we try to train the neural network model to learn the language. It's because there are clear relationship between the different part or the different words into a certain sentence, and the objective of the attention is to calculate this relationship between all tokens. وإلا نسميهم words الآن. مش نتكلموا على التوكنز ولماذا نحتاج tokens. في الأخير a token is a part of a word. And you will understand why we need tokens and we don't work with word into a vocabulary. And we will assign attention weights that will capture these relationships ما بين الكلمات. so that I can make generation that makes sense. I don't make random generation. And this solves the limitation of RNN and LSTM to also capture long-range dependency efficiently and not only short-range dependency. فهذا أول شيء لازم نفهموه. لماذا صار التحول؟ لماذا ال LSTM وال RNN are not sufficient to generate a language like we see it today with ChatGPT or with Claude or with Falcon or with these language models. لأنه the previous models, they were failing to capture the relationship into a wider context. Okay, the context was small, so they have limited capabilities. That's why they were successful in doing sentiment analysis. يعني sentiment analysis غالبا جمل تتكون من 20 كلمة 30 كلمة في السوشيال ميديا. That's something doable. لكن they were failing into doing efficient translation. تتذكروا جوجل ترانزليشن 2015 2016 very over يعني تمشي له فقط إذا أردت تفهم معاني كلمات لكن you cannot rely on it just to copy paste and use the translated. But now, okay, still Google Translator is not the best, but ChatGPT can do something like nice translation. Okay, and there are more sophisticated translation tools that provide excellent outcomes because now these machines have learned from a wider context the relationship between words, and they were able to bring you the right word into the right context. That's what matters. So it's not only a problem of scale of the data, it's a problem about capturing the relationship between the big scale of that data. And that was the challenge that this self-attention module has tried to solve. And it's basically, the concept is based from the information retrieval area. So this concept is not new. It was brought from information retrieval and then was adapted as a new layer that will make an attention between. So we will have like a vocabulary, the whole vocabulary. We will have a keyword and we will have a query. And we will calculate kind of a semantic relationship between a word into a sentence. We will explain this in detail when we talk about the transformer architecture. Okay.
هذا البيبر اللي عرفت الترانسفورمر.
هذا البيبر اللي عرف ترانسفورمر. هذا البيبر اللي قلب الاي رأسا على عقب. وبالحق it's impressive يعني the things that we see now in language modeling is something that was even difficult to think about a few years ago. Okay, لأنه a machine that can do everything. Now حتى البرمجة. أنا تو الآن مثلا في البرمجة نستعمل cursor AI. Just pretty much do only prompting. But of course you need to have a background on programming. But if you have a sufficient AI programming background, just not to know how to make good prompts to generate your code professionally and quickly. This is one of the use cases. والمستقبل أكثر. يعني in one day we will have very complex systems just built with the simple prompts. Okay, one of the things, for example, that I've tried to do with Cursor AI, I wanted to develop a full stack application that contains React and Django. These are two, واحدة الفرونت end وواحدة back end. And these are two complicated frameworks. I just provide the description of the application, the description of the front end, the back end, kept the AI works in 10 minutes. I had a complete project set up. If I give it to two engineers, they will have to spend 2 days or 3 days just doing the initial infrastructure of the code. Only 10 minutes. I didn't do anything. Just make the description, put it there, and you know, it doesn't only do prompt. It will do iterations when it makes mistakes. It understands the mistakes. I need to make permissions on the drive. I need to search from the internet. Now there is an error. I need to install this package. I need to install that package until it completes everything. It can make mistakes, but still, you know, it's much more efficient than even professional developer engineers. So you can see the level of AI now. It's really tremendous. Okay, and you know, not only on this now, there are AI platforms that can review a full paper. There are AI platforms that can write you a paper. Okay, still not 100% sophisticated, but still they can save you 70%, 80% of your time. Now, at the end, you can focus about your ideas, and the AI will help you, for example, in writing, in proofreading, in editing. This is what most of the people fail to do, because especially new researchers, they are not very, they don't know the standard of writing. They don't know what to write in abstract, how to write an introduction. Of course, there is a need to learn, but when you learn, you can actually use AI to help you, reduce the mistakes, grammar mistakes, or improve the writing standards. So the self-attention, as already mentioned, it captures the relation between all input tokens in a sequence. Let's make a break. بعدين نواصل إن شاء الله. بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. So let's continue talking about the self-attention. As already mentioned, the self-attention captures the relation between all the tokens into an input sequence. So here we talk about long-term relationship and dependencies, and assign attention weights to focus on the most relevant parts of the input. So the key steps is, first, it will take input features, which is a vector representation of the text with the position. We will talk about all these details, and then we'll calculate attention scores, and finally make an aggregation to combine the weighted features, and finally produce the output. This is part of the transformer architecture, which is represented by this one. So basically here we're going to have an input embedding which represents the sentence as a vector representation. It will go through several self-attention heads. It's like we have many convolution layers in a convolution neural network. And then we have normalization to reduce the problems of vanishing gradient descent and exploding gradient descent. And then feed-forward network. This is a dense layer. Okay, this architecture, it's the first architecture proposed for the transformer for machine learning. This is why we have two parallel blocks, one to take the input and one to take the translation. So we will map the translation to the input text, and this the encoder will be able later on to translate any input text into the target language. So this is just a high-level definition of transformer. Of course, we will go into all the details, but I would like to mention how did we get to self-attention. So, of course, when we talk about NLP, we talk about sequential data. It can be text, it can be DNA in case of healthcare, it can be medical reports as maybe text, time series data, video images. Also, transformer was applied to vision transformer. We take an image, instead of considering pixels, we will divide the image into patches. From 1 to 16 in the beginning, it's like, and then we will consider these patches of images as a sequence of fragment of images, and then the self-attention will focus on the features. So, and traditional sequential model based on recurrent neural network, they were able to process different type of input and output. So we had one-to-one input, output, one-to-many, many-to-one, many-to-many in different ways, whether with equal input and output, feature size, or different. So let's take them one by one. But first of all, the concept of RNN and language modeling, I found this paper from 1990. It presents almost most of the concepts that you can see nowadays in language models. So this paper is finding structure in time. So this means it's dealing with sequence. Okay, and this paper talked about the temporal representation in neural network. So to represent time-based patterns in neural network, which is essential for sequential data processing. Okay, so you can see the concept of RNN is quite old as a concept by itself. Okay, and defined also the problem for recurrent neural network, which are networks with directed temporal connection. Okay, and dynamic memory in the network, because we need to capture the relationship between the different items in a sequence. And let's dive deeper into this paper. Okay, so this paper also presented the internal representation of sequences. It's a pioneered understanding of temporal sequences processing. and forms the foundation of modern large language model text processing. Look, this was one of the diagrams that actually represent what we know today as recurrent neural network. We have input units and the context unit. And it's like trying to find the relationship between like a keyword inside a sentence, because a sentence is kind of the context. And here we have the hidden unit. And the hidden units are part of a neural network. We have hidden layers, okay, even in a recurrent neural network. And look, in short, the network must be given a memory. So the concept of memory started from 1990 as an essential part in order to process sequential data. It means data that has a time step relationship. Because now a sentence, what is the relation between text and time sequence? You know, because a text, it has an order. When you have a sentence, the words have logical order. If you scramble them, so the sentence will not make any sense. So there is the concept of timing or sequence modeling, because the position of each word in a sentence is part of the sentence semantic. Okay, so this is very important. And it has also defined an important concept about the encoding, which we know nowadays as encoding or also embedding. It means how can we represent a word using a vector representation. And you know, vector representation came back later on in 2013 with word2vec, which transforms a word into a vector. So this paper is a seminal paper. It presents most of the foundation of language modeling that we know nowadays. Okay, so it talks about types, token, structured representation. All these concepts are major parts of language modeling. So let's look at the traditional language modeling approaches using RNN or LSTM. You know, so we have one-to-one. This is used like binary classification. Okay, you can provide an input, and you'll have an output. You know, whether true or false, positive or negative. This is an example of binary classification or sentiment analysis with positive and negative outcomes. We can use also recurrent neural network for image captioning. We provide a picture, and at the end we can have a sentence. And here we have one-to-many. We have one input, and we have multiple output. We can generate a caption for an image. Another example is that we have many-to-one. So I can have a sentence and finally generate a sentiment, whether it is positive or negative. We can have machine translation, many-to-many. And the problem with machine translation, look, I can have an English sentence of 4 words. It can be translated to 3 words. Okay, so we don't know in advance the length of the sequence. And this is one of the challenges in sequence language modeling, is that there is a dynamic nature of the sequence length or the sentence size. So it can be translated differently as well. So the challenge was how to make this recurrent neural network learn the patterns in order to produce the desired outcomes. Okay. Now, let's even go backward to the original of neural network. So a neural network, basically in the very basic use case, is what we call the perceptron. A perceptron is just one neuron that take input features as a vector, x1, x2, x3. It will be multiplied by weight. We can add bias. And this is called a linear transformation. Very simple, you know, ax plus b equal to linear transformation of x. And then it will go, so the sum of all these weights multiplied by the features, and then we will do a nonlinear transformation. It's a nonlinear function like the sigmoid, or the softmax, or the tan h, depending on the context, and this will provide an output. And this is the linear algebra representation in a matrix form. W is the matrix of weights multiplied by x plus certain bias. You multiply by linear transformation. And finally, you will calculate a loss function This is if you have binary classification, the cross entropy function that you need to minimize in order to optimize this network. So this perceptron, it can work when we have small number of features and very simple task. Okay, for example, estimating the price of a house based on 3 or 4 features, like the area of a house, the location of a house, the number of rooms. These are features, and you can estimate a number, what is the area of the house. But when you have much more complex data with multiple features, the features are very complex, one neuron is not sufficient. So in this case, we can duplicate these neurons such that each layer is going to learn some particular patterns. If we have complex patterns, neuron يعطيك one pattern، لكن يمكن عندي many patterns، مثل الصورة متاع القط فيه الedges، فيه العيون، فيه أشياء مختلفة. We can duplicate the neuron in order to learn as much pattern as possible, especially if I have very complex patterns. And you will have a fully connected network with different weights here, nonlinear transformations, and we can have multiple outputs. This is what we call feed-forward neural network, and usually we start from real numbers to real numbers. You know, a neural network does not do anything, only matrix multiplication and function application, okay, and then back propagation to learn. That's it. That's a feed-forward neural network, or we call it also dense neural network. Okay, so we come back. Feed-forward network is an alternative to perceptron in order to capture multiple features. So you can think about every neuron is going to capture a particular feature of the complex pattern that we can learn from the data. Okay, now imagine that we want to use this feed-forward network to handle temporal data in sequential models. مثل ما عندي نص text. We have a sequence of characters. Now we have a dense network. We map a word to an outcome. Okay. So in this case, if I have multiple words or multiple tokens, you can think about x0, x1. These are words into a sentence. And we will put everyone in a dense neural network to provide an outcome or an output. What's the issue with this? So here we have the output y is just a function of xt. What is the limitation for modeling a sequence? What it does not capture? It's like they are independent features, but the words in a sentence are dependent. They have relationships, so it doesn't capture the relationship. فالفكرة بتاع neural networks تقول I will add an additional input from the previous output. So this is the first sentence. The word provide an output y0, and I will take a hidden state to be also an input with the next word. So this output will be dependent of this word plus the outcome of the previous one. This is a hidden state. What we call the hidden state. It comes as a result from the previous neural network. And the same thing, now if I want to make inference with x2, so I will take the hidden state of h1, which is kind of a combination of the two previous tokens. But it's not a memory. This is kind of a digest. You know, it's a latent space. It's a feature vector representation that I will use from the previous. It will capture the temporal relationship. But as I go deeper, the impact of the first token will be smaller than the impact of the closer token. So this is like it has a memory of 1, just the previous state. Like RNN, they fail in order to carry out information from old tokens or old words. And look now at the function. The output will be a function of the current state and the previous state, which represent the memory. And this reminds us the paper of 1990 that talks about the memory and the temporal representation. Okay, this is a recurrent neural network cell, and we can represent this, you know, as just one dense layer that is recurrent, like this. So this representation is equivalent to this representation, and this represents a recurrent neural network, xt. Okay, So this neural network will provide an output based on xt and the previous hidden state to provide this outcome. Does it make sense? Okay. So in this case, the inference will be based on the current state, the input, and the previous state. So recurrent neural network are a great tool to capture the temporal relationship, but with some limitations, of course. This is a pseudocode that represents how to do the next word prediction in a recurrent neural network. Because what is text generation? You have a sequence and you want to generate the next word. Okay, so here an RNN, it's defined by a word and the hidden state. So the hidden state is just the activation function, the nonlinear function, multiplied by the linear transformation of the word, which is the current state and the hidden state, هذه F function that you have defined. And then we do the prediction, okay, by applying the output weight to the hidden state plus the bias. So we take this hidden state that we calculated. This is ht minus 1. This is the current ht. So this will make the prediction based on the previous context, okay, because it's recurrent. فكل ما ندخل sequence, السيكونس هذه مش يكون عندها تأثير on what is going to come next, because it was trained in this way. Okay, don't worry about the code. Just for people who are familiar with coding, you know, they understand this is just the function that you have written in pseudocode Python. And this is how to make RNN inference. So it's another way to represent the code. Okay, so the sequence modeling design criteria is that we need to have, so the sentences, they have variable length sequences, which makes a challenge. So the model must efficiently process sequences of different length, okay, that can vary from short input to long inputs. They must have long-term dependencies, and this is to ensure the ability to recognize and maintain the relationship between the elements or the words into a sentence. هذه الخاصية الثانية بالنسبة للسيكونس modeling. الخاصية الثالثة direction of the information flow، يمشي في اتجاه واحد. When you read the sentence بالإنجليزية تقرأه من اليسار إلى اليمين. بالعربي تقرأه من اليمين إلى اليسار. You have only one directional flow. You cannot make it bidirectional. And this makes flexibility to process information in one direction or both direction depending on the task. يمكن بعض الأحيان يكون عندك both direction لما يكون عندك إكمال النقص في الكلمة في الجملة. نعطيك جملة فيها كلمة ناقصة، لازمك تقرأ السياق الأول والسياق الأخير باش تعرف كلمة في الوسط. But some of the tasks they require bidirectional flow. Some of the tasks, when you make text generation, it's unidirectional flow. And the order of information, of course, we need to maintain the order of the sequence. You cannot scramble the word order into a sequence, otherwise you will lose the meaning. So these are the sequence modeling design criteria. Okay, so variable length sequence, I can write sentences with different lengths. AI is a breakthrough technology, whether AI stands a pioneering technology today, or artificial intelligence represents the forefront digital solution. All of them, they mean the same thing, but they are written differently. And this makes a challenge. Okay, we need to have long-term dependency. So, for example, look at this sentence. Despite the cat's initial fear, the dog became its best friend. ففرند هنا ترجع على كلمة cat. So RNN doesn't have the ability to capture the relationship between this word and this word because it has only one-step memory. So LSTM came in order to create a short memory, which is defined by a window, which is a hyperparameter, okay, in order to try to capture as much semantic as possible within a sentence. So RNN process sequential data by passing hidden state through time steps, but the challenge, RNN struggle to maintain the context between distant input and output. And this is why LSTM came into the picture, and without going into details, there are some gates that were defined in order to carry out information from the previous state directly over this channel, so to maintain this kind of relationship between words that are distant into a certain sentence. So LSTM enhances the memory architecture. It manages extended sequences and prevents gradient loss via controlled memory. We will have a full lecture about language modeling using RNN, LSTM, and GRU. Now, limitation, the RNN and LSTM both they have limitation. It's true that LSTM is able to mitigate the issue of the memory, but still it's limited. It's a short memory. Okay. Another issue is the encoding bottleneck. Okay, and this means compressing all sequence information to fixed size vectors lead to the loss of context, especially in long sequences. This is one issue. The problem is slow and non-parallelization. When you process in recurrent neural network, you need to process the word one by one. You cannot make them in parallel. فلو عندك long sequence, you need to process them one by one, so you lose the parallelization of processing capability. وهذاك علاش يكونوا بطيئين نوعا ما. Okay, that's another issue. Sequential nature of RNN prevents parallel processing. واضحة هذه؟ لما باش تقرا جملة تقراها واحدة بالواحدة. You will process the word one by one. Can you process it in parallel? No. When we cannot process in parallel, we cannot save time. لأنه لازم ننتظر السياق السابق باش نعالج اللي يجي من بعد.
عشان كده
slow. Okay. Time consuming inference. The inference is time consuming. And it has a short memory. It struggles to capture long-term dependency. مثل ما تكلمنا العديد من المرات. Due to the vanishing gradient. خاطر لما نكبل الميموري يأثر في الجريدينت computation and leading to poor performance on extended sequences. لذلك علاش ال LSTM ما نجحش في many tasks خاصة لما تكون نصوص كبيرة جدا. لذلك ما استطعناش نعملوا نماذج لغوية ضخمة باستخدام ال LSTM ولا ال RNN based technologies. فلازم نفهموا السبب. ولذلك لما اللانجوج موديلينج بدأ من 2013 وكانوا يحاولوا بالطرق بدل ما كانوا يحاولوا بالماشين ليرنينج في المانيوال فيتشر اكستراكشن، يعني في محاولات في الماشين ترانزليشن في الناتشورال لانجوج بروسيسنج but still limited to some small context size. فالريسيرش كوميونتي they were looking for alternatives on how we can parallelize, how we can train, we can speed up the inference time, we can extend the memory. كان أكبر مشكلة هو الميموري. Yes.
هل self-attention more costly in terms of money?
هو it's very costly in terms of computation لأنه quadratic complexity. Okay. لكن في الآن other variants of self-attention مثل الفلاش attention, they try to make it even less costly. وفي الآن a new architecture called Mamba, they have even linear complexity for and it's based on different technique.
So then why do we still studying RNN and LSTM?
Yeah, it's still useful for small tasks, you know. Language model usually they are big in size, heavy deployment, costly in terms of deployment. So for small tasks, sentiment analysis, you don't need to have ChatGPT-4 deployed on your computer to make simple tasks. So we can still use these simple techniques for quick and simple applications. But now for sophisticated application, transformer was actually the solution to overcome these limitations. Now, thinking again back about removing these bottlenecks, how to eliminate the need for recurrence ولا sequence processing. So we have a sequence, which is the context, and we want to produce an output, and we used to use this hidden state to transfer the information from one state to another. So what is the idea to avoid all the problems? The bottleneck والparallelization والlong-term memory. قبل السيلف اتنشن مش نعرف الكونسبت درسناه من قبل. احنا الان كنا نعالجه قلنا مش نعالجه لما نعالجه in sequence we cannot make parallelization. شنو هو البديل؟ مش ما نعالجوش in sequence. We don't process in sequence. احنا عندنا شيء يا process in sequence والا الكل مع بعض. صح ولا لا؟ ايش معنى الكل مع بعض؟ ناخذ سنتز خلاص كله انجكتد في النيورال نتورك مع بعض. ما انقسمها، دخل الكل سيكونس كاملة. هذا الشيء رجعنا للكونسبت تاع ماذا. رجعنا للأصل الأول، الفولي كونكتد نتورك، فيتشرز والكل مع بعض، ندخلهم في some kind of machine learning model, deep learning model, whatever، ويعطيني sequence to sequence.
بس كيف بيصيروا سيكونس؟
أي هذاك الآن الاركيتكتشر اللي باش نتكلم عليها. فمن حيث المبدأ الترانسفورمر تكنولوجي هي الخروج من السيكونس موديلينج بالار ان ان ونرجع للفيد فورورد نتورك اللي ندخل كل فيتشر مع بعض ويخرجوا لي اوتبوت مع بعض. In simple words. واضحة الفكرة؟ It's like going back to the original architecture اللي هي الفيد فورورد نتورك. طبعا here we will have some kind of feature extractions اللي هو self-attention. في موديول هنا جديد اللي هو self-attention to extract the features and provide the output اللي هو text generation ولا any kind ولا image generation ولا depending on the task. in order to remove، فالفكرة منطقية نوعا ما، لكن تطبيقها هو الجينيوس. تطبيقها هو الجينيوس. أنا نقول خلاص أنا الآن هذه ما عادش تلزمني، عملت لي إشكاليات في الباراليزيشن. I need to process a sequence. Long term memory I cannot because I don't have a fixed length. So here I'm going to provide a full sequence. طبعا here I have a context window. مثلا I will accept 1000 word. حتى لو الجملة عندي فيها 5 كلمات لازم يكمل padding. دائما المدخل 1000 word. واضح؟ this is the idea. This is why now large language models ChatGPT هل تستطيع تعطي نص infinite؟ في عنده context window. هذه ال context window. It's the maximum number of token you can put in the input. واضح؟ طبعا أول ما بدأ تشات جي بي تي كان فيه 4096 input token، الآن يوصل ل 128,000 input token، وبعضهم even they can go even bigger. large language models they have a fixed size of input and a fixed size of output. هذا يعتبر total context length. That's one of the limitations. طبعا if you increase the input sequence you have to increase the network. Everything will scale up. لذلك علاش الآن أصبح matter of scale. We talk about trillion tokens to train and trillion parameters. Okay. الآن ChatGPT 4 يقول أنه 1.7 trillion parameters. ChatGPT 3.5 175 billion parameters. Okay. And the big companies they are increasing in scale. طبعا في طرق أخرى الآن not to increase in scale is to build small models which we call them experts, and then the large language model will be a mixture of experts. سمعتوا شي بالديب سيك. This is the latest trend now in open source large language models اللي هو Chinese competitor. بصراحة China now it's almost to catch up with OpenAI, and this is the first open source model that convinced me kind of يعني has a comparable performance with ChatGPT 4, not at the same level. لكن جربت الميتا مثلا لما 3.2 3.3 يعني still يعني. لكن to be honest DeepSeek is one of the open source, the first open source that attracted my attention in terms of quality of the output for some complex tasks that I used to do with LLMs. And it's based on model of experts, and each expert model is trained on 37 billion parameters. So this is a way to overcome the issue of scaling bigger models. So they will train specialized model, one model for encoding, for coding, programming, one model, for example, for machine translation, one model for reasoning, one model for, I don't know, they will train multiple models on different type of data. When you submit a query, they will try to classify it and route it to the appropriate model. And this model can communicate together to achieve coordinated tasks. This is one of the trends now in large language models. Okay, let's try to move, again, everything is based on this nice paper, although it's not an easy paper to read. It's very technical. But there are so many tutorials about attention, self-attention that you can find blogs. The best resources on AI now are blogs and internet content. Textbooks, if you read textbooks after 6 months, it will become outdated. But people keep writing and updating blogs, internet content. So you'll find many resources available. Now, let's define the concept of attention, الانتباه. What do you see in this picture? Mountains and ice. Okay, so here you didn't pay attention, because if you pay attention, you will find something else. Now pay attention, what do you see?
Tiger.
A leopard. Okay, فهذا نفس الاتنشن في الكمبيوتر فيجن ولا في ال LLM. الانتباه. ايش معنى الانتباه؟ يعني I try to find features into some complex patterns. Now this is a feature. Look, now if I get back to this picture, your eyes will go to the leopard now.
Yeah.
Okay, but it was you are not able to see it before. There are features, but I need special effort, which is called attention, to be able to capture this part of the picture. طبعا في الكمبيوتر فيجن فيه special type of attentions. They are not called self-attention. في special attention و channel wise attention, combination of both. كانوا موجودين في 2017 قبل السيلف اتنشن يعني. They were applied and they were able to solve these kind of problems. This is the concept of attention in computer vision, and same thing also applies to natural language processing. Now, if I tell you how to read this word, خبر, خبر, خير, خبز, جوانين شكلكم. Okay. الآن we don't have any context, so I am able to read this word in different ways. So I don't have any certitude. If I say generate this word, I will have a chance to generate what. If I tell you generate what is the word in my mind, ممكن أنا نقول خبز مثلا وأنت تقول لي خير. You have probability of error. ممكن you have 10% chance to get what I have in my mind. لكن if I provide more context, like this one now, like this one. طبعا احنا شفناها الان اصبح يقين. انا لو اقول اشتريت حبره وانا اكلته، طبعا اشتريت حبره ممكن، اما اكلته اصبح صعبه. فالسياق الان مرتبط بالسابق واللاحق. كيفاش عرفت كلمه خبز الان هذه؟ طبعا من اللي مر عليك السياقات اللي قراتها من زمان. فالهيوج اماونت اوف داتا والكتب اللي قراتها والتكست بوك وكل اللي مر عليك يخليك الان you have the ability to make correct inference. لو نسأل نفس السؤال الشخص ما زال في الابتدائي سنة أولى يمكن يغلط، لأنه ما مرش عليه معلومات كافية باش يعطيني the correct prediction. فنفس الشيء اللانجوج موديل، إذا نعطيه نصوص قليلة جدا يمكن يخطأ يمكن يصيب، في احتمال. لما نكثر عليه المعلومات ونعطيه نصوص من عشرات آلاف الكتب وملايين المعلومات, it will capture something. Okay? And with the efficiency of the architecture, we can have models at the quality that you are seeing today. But the first thing is that you are going to learn from the context. ناخذ مثال ثاني. خبر يقين. عنديش نسبة خطأ؟ ما فيش. فنفس الشيء. الفكرة الآن how can I train a machine such that when I give a context it will provide me a correct prediction. شفت المسألة بسيطة في المطلق. لكن صعبة في التطبيق. اوكي. فالفكرة الآن قال اوكي خلينا نجمع أكبر عدد ممكن من البيانات النصية. And then we train a model. And this model has to have the ability to capture the relationship of any word within any context. الكونتكست هذا it has to be defined in advance. 1000 كلمة 2000 كلمة 10000 كلمة 128,000 كلمة. So now we will talk about long-term dependency of the words. تخيل أنت you will provide sentences and then you will ask the machine learning model or deep learning model to develop relationship between these different words. So it has to make attention on the relationship between these words within a context, so that at the end it will have the ability to predict what will be the next word given a particular context. This is the phase of what we call the pre-training model. Pre-training model يعتمد collection of a huge or massive amount of data to train a model on making inference such that given a context it will give you an output. على قدر ما يكون الكونتكست واضح على قدر ما يكون الاوتبوت احسن. لو بقول انا فقط قرأت ممكن تعطيني جمل مختلفة، نزيد هذه مثلا بدون الكونتكست هذا. ممكن تكون خبرا وتكمل أشياء أخرى، أو قرأت، يعني هذا يحدد نوعا ما السياق. ولذلك أن تشات جي بي تي أو large language model when you don't provide sufficient context it might not respond accurately to your question. أوكي، فعلى قد ما تكون accurate في البرومبت اللي نسميه احنا prompt، البرومبت هو السياق، لأنه هو في الأخير شو يعمل؟ it will make completion. chat GPT doesn't reason، عنده ability of reasoning، لكن inherently it doesn't reason. It just generate the most likely word in the sequence. بس بتقول كيفاش تعلم هذا الشيء؟ طبعا هذا يأتي ضخم البيانات. Okay, and also the architecture of self-attention that has the ability to efficiently capture this relationship between the words. لأنه استعمل recurrent neural network على نفس البيانات الموجودة it will not learn the same patterns as the transformer has the ability to learn. Here we have several parameters اللي هو the amount of data, the scale of the network, and the efficiency of the feature extraction network. اللي هنا feature extraction هي the relationship between the different words in the sentence. فالآن معروف حبرا واضحة. أوكي، فبالطريقة اللي تعلم بها البشر نفس الشيء تعلم الآلة، أنها تتعرض إلى نصوص كثيرة جدا وتبدأ تتعلم على كيفية إنشاء النص عن طريق السياق. لقد قام بجبر خاطر هذا المسكين، من كان يؤمن بالله واليوم الآخر يقول خيرا أو ليصمت. كل نفس الأصل لكن تختلف على حسب. فالسلف attention at the end what it will do, you know, this is kind of an intuition, but you know it's even more complex in practice. It will try to have context and then calculate what we call attention scores. Attention scores is like, for example, look now, of course, every word will have complete the highest attention with itself. لكن مثلا الشراء والخبز يمكن يكون عندي سكور بتاع 50% من الشراء، يمكن يكون فقط ما هو فقط الخبز، يمكن اشتري سيارة، اشتري أي شيء. فممكن السياق of اشتريت it can be applied to different type of words. فالattention score will be affected by how often I find this word within this context. Okay. الاشتراء والأكل قد يكون أضعف، الخبز والأكل قد يكون أقوى. فطبعا العلاقات هذه تتكون من الكوربوس، ولذلك نطمح أن يكون عندنا بيانات من from different disciplines from different areas. لو تشتغل فقط على مجال واحد مثلا نيوز يخليك في إطار ضيق، لو في مجال طبي يخليك ضيق في المجال الطبي. طبعا depends on if you want to make a general model like large language models ولا specific model, that's your choice. لكن your input is this is what is going to affect your output. لو تعلم فقط على مصطلحات طبية خلاص تخرج الجانب الشرعي ما يفهمش. لو تعلم على مصطلحات صحافة ما يفهملكش في مجال العلوم. but usually this corpus خاصة الآن شكون اللي سوى النماذج اللغوية الضخمة؟ جوجل وأمازون they have access to all kind of data. You know, all our data is with them. You know, they use it without our consent to build all these models. يعني حتى في وقت من الأوقات نيويورك تايمز حبت تعمل قضية بأوبن اي اي خاطر هي أخذت بياناتها وتستعملها من الآن to generate something like، لكن خسرت هي في الأخير نيويورك تايمز. They want to. This is the idea of self-attention, is to create an attention feature map, which is basically try to capture the relationship between the different words into a sentence. And from there, later on when we make an inference, given a certain initial context, the machine learning model is able to predict not even the next word, it's the next token, even more complex.
طب يعني بعد ما يسوي self-attention matrix بعدها يحسب النكست وورد probability.
أي إذا خلصنا التريننج الكل أصبح السيلف اتنشن المكتمل، أصبح عندنا نموذج. النموذج هذا خلاص نعطيه سياق يعطيني completion.
بس كيف يقول لي هذه الكلمة بدل هذه الكلمة بدل؟
لا هو it's a pool of words. على كل سياق عندك مثلا 100 توكن محتمل، 100 كلمة محتملة. And then you have different approaches. تقول له أنا فقط اختار لي دائما the highest probability word. هذه طريقة، لكن الطريقة هذه سيئة. لأنه دائما لو تعطيه نفس السياق 100 مرة مش يعطيك دائما نفس الجنريشن. أحسن أفضل احتمال في أفضل احتمال greedy approach. this is conservative. It's not prone to hallucination. بتعرفوا مسألة الهلوسة. يعطيك اشياء منطقيه لكن ما فيهاش imagination، ما فيهاش creativity. فنقول له لا، انت الان مش لازم تختار the highest probability، you can choose يعني second one third one. there is a parameter that we call temperature اللي هو يعطيني مستوى الكرياتيفيتي. 0 it means deterministic، دائما highest probability and this is not good in general only for very specific task اللي نحتاج انه يكون دقيق جدا في الاجابات. لكن مثلا to write ولا to make something more creative we need to be flexible. I can choose lower probability tokens to generate something new، لكن دائما في اطار المعقول. طبعا if you can make it too creative يصبح يهلوس، يجيب لك اشياء ما عندها معنى، يجيب لك اللوس probability يعني اي شيء. انت الفوكابلري لو عندك فوكابلري مثلا متكون من مليون كلمه، ممكن تقول له اختار من 10 الاوائل من 20 الاوائل، اما كي تقول له اختار من 100,000 الاوائل تولي اشكال. ف this is a problem of inference we will see when we talk about language modeling. And with this we complete the lecture of the day. Sorry we took 10 minutes.